Hello everybody, and thank you for taking interest in our paper called People Counting Solution using a frequency modulated continuous wave radar with knowledge distillation from camera data. I am Stephan, a PhD student with the Friedrich-Alexander-Universität of Erlangen-Nürnberg and Infineon Technologies. I'm one of the co-authors of the paper next to Souvik, Hazra, Avik, Santra from Infineon, and Professor Robert Weigel and Professor Georg Fischer from the University of Erlangen-Nürnberg. The goal of our work is to count the number of human targets in indoor environment using a low-cost radar sensor. Indoor environment could, for example, be office spaces or elevators. So, for example, for sensing the current capacity or the current occupancy and whether this is below or above the maximum corona capacity of these indoor rooms. Some challenges in these indoor environments are occlusions due to furniture or other people in the room, ghost targets mainly through multipath reflections, and way more challenges. Also, the low-cost radar sensor has a limited range resolution, at least a limited FFT range resolution, and a limited angular resolution, due to having only 1 GHz of bandwidth and 1 TX antenna and 3 RX antennas. The contribution is obviously the people count solution itself using radar sensors, but also showing that using the cross-modal information from a network trained with camera data helps in improving the accuracy. So here we can see the radar sensor, pretty small. So the proposed solution has this radar processing pipeline and this camera processing pipeline, where only the radar processing pipeline is used during inference. Here we are using basically micro and macro Doppler information. What we call micro and macro Doppler is basically just looking at different time durations. So using information from one frame to create the range Doppler images and using information from multiple frames to create the range Doppler images, so that we have high and lower velocity resolutions as input images for static and moving targets. And then we have some camera processing chain to get heat map images of the human targets to train a network with triplet loss, and then the main part is this KL divergence loss term, which we use between the embeddings after softmax activation to make our radar network learn the semantics of the camera embedding space. We trained these networks with recordings of up to 6 people moving and standing around in different indoor environments, like for example this office space, as can be seen here. We also have some nice results. The main result is that we show that using the cross-modal information or using knowledge distillation from the more powerful sensor, that is the camera sensor, we can achieve better accuracies. So on the left side we have a network trained purely on the radar data, and on the right side using the camera information, and we achieve a much better accuracy. This is then for a radar sensor trained on a new radar sensor in a different room evaluated. Yeah, that was it, and I'm up for more questions, and you can also look at our paper. Thank you.